Day 146 of doing a LeetCode problem every day until I get a job. All right, y'all, welcome back to another day, another LeetCode problem where we're doing a LeetCode problem every day until I get a job, or we might just do a LeetCode problem until we feel some sign of burnout, or we might just do a LeetCode problem until they're all done. Who knows? But all I know is we just keep doing LeetCode problems every day, and I don't see any sign of stopping anytime soon. I know this page is about discipline and consistency, y'all, so I encourage y'all to stay disciplined and stay consistent, y'all. We're trying to help motivate each other to keep going and keep pushing through until we all accomplish our goals of being the best programmers that we can be. And in order to do that, we're going to need to get some of this LeetCode practice in, so y'all have come to the right place. And before we get started today, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. Then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we could help push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community grow and do what we need to do to get more people interested in learning about the Swift community as a whole. And one way we could do that is to get this Swift content out to as many people as possible, y'all. So your support is appreciated. Now, with all that being said, y'all, let's get to the question, the part you've all been waiting for. And today we have question number 657, robot return to origin. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well, because we're all on this channel trying to learn something. And if nobody can understand the code that was written, then nobody will probably learn anything, and that is not what we want, y'all. So let's see what the question says. It says there's a robot starting at position 0, 0 with the origin on a 2D plane. Given a sequence of its move, judge if this robot ends up at 0, 0 after it completes its moves. You are given a string moves that represent the move sequence of the robot, where moves I represents the ith move. Valid moves are R for right, L for left, U for up, and D for down. Return true if the robot returns to the origin after it finishes all of its moves, or false otherwise. Note, the way that the robot is facing is irrelevant. R will always make the robot move to the right, and L will always make it move to the left, etc. Also assume that the magnitude of the robot's movement is the same for each move. Okay, y'all, so I know that can be a little confusing, so let's look at the example so we can see what they mean exactly. So we have, right now we're on example 1. We have the input is moves, it's a string of UD. The output is true. The explanation says the robot moves up once and then down once. All moves have the same magnitude, so it ended up at the origin where it started, therefore we return true. Okay, so let's see. We want to know if the robot ends up back at 0, 0. So it's going to start at 0, 0. We want to end up back at 0, 0. So let's draw that out real quick, right? So first, let's say this is 0, 0. We put a 0, 0, 0 right here, right? We just put a 0 right here, right? So the moves are up and down. So say, well, hold on. Let's get all this in order first so we can move up and down. My bad, y'all. 1 minute. Okay. So it says the moves are up and down, right? So we go from 0, then we go up. Boom. We go from 0, then we go up to 0, then we go down back to 0. So that's the move. Up 1, then we go down back to 0, right? So, or it'd be like this. My bad, y'all. Say 0's right here. It goes 0. Say the 0. Oh, shoot, man. Oh, let's see. My bad, y'all. Well, yeah, let's just say the 0 goes up, and then it goes back down, right? It goes up, then it goes back down. That's all it did, so it ends up back at 0, 0 at the end of the day. UD, that's why the output is true, right? Because it went up, and then it went down and it's back at its original place. And so that's why the output is true. So let's look at example 2. Example 2, we have the input moves equals LL, so that's left, left. The output is false. The output is false because the robot moves left twice. It ends up 2 moves to the left of the origin. We return false because it is not at the origin at the end of its moves. So if it's right here, we go left once, left twice. That's all it is. That's not back at 0, right? That's why we return false, because it then returned to its origin, right? We started right here, we went left. That then start back at its origin, as compared to the first example when we started right here, we went up and then we went back down. We back at the origin. Example 2, we went left, and that's not back at its origin. You know what I'm saying? If we went left, then right, then we'd be back at the origin. But that's not what happened. We went left, then we went left again, and that is not back at its origin, and that is why the output is false. So let's get into the code now that we understand what the question wants us to do. And the code's not that difficult, y'all, at all. And once you see it, you're going to be like, oh, this was way easier than I thought it was. It's all about training your mind to think as a programmer, y'all. That's part of what LeetCode teaches us. It teaches us how to think like a programmer. And this example, or this solution, is an example of just that, once you see how easy it really is. Right now, it may seem a little difficult, but it's not difficult at all. First thing we're going to do, we're going to say let up. We're going to colon, cast that as a character. We're going to set that equal to, we're doing up, so we're going to set that equal to U, right? Then we're going to capital U. Then we're going to do the same thing for down. Cast that as a character. Set that equal to capital D. Then we're going to do the same thing for left. We're going to say let left, colon, character equals quotation marks with the capital L in between. Then we're going to do the same thing for right. Let right, colon, character equals quotation marks with the R in the middle, right? So now we have our up, down, left, and rights. Then we're going to say let up count equal moves dot filter. Open up the brackets. Then we're going to do $0 because $0 is going to represent each element in the string that we're dealing with, or each character in the string that we're dealing with. So if we're going through all of the characters, this $0, we're going to say equal to up dot count. So what this $0 is going to do is it's going to check every character in the string to see if it's equal to up or equal to U. And if it is, it's going to keep count. It's going to store count of how many times we see this U character, basically, or we see something that is equal up, which in this case is the U character, because that's how we set it up. Then we're going to do the same thing for down. We're going to do the same thing for all of them, right? So we're going to say let down count equal moves dot filter, open up the brackets, $0 equals down dot count. So what this is going to do is it's going to count all of the characters in the string that equal down, that are equal to down, or that are capital D. Then we're going to do the same thing for the left. We're going to say let left count equals moves dot filter, open up the brackets, $0 equals left dot count. And then this is going to do the same thing. It's going to go through the whole string and find every character that is equal to capital L, which is left. Then and it's going to store the count. Then we're going to do the same thing for right. We'll say let right count equal moves dot filter, open up the brackets, $0 equal sign. Excuse me, this time we're doing right dot count, and same thing. This is going to loop through every character in this string, and it's going to see which characters are equal to capital R, which is going to be our right. Then we're going to come down here. We're going to say if up count is equal to down count and right count is equal to left count, then we are going to return true. And if not, we're just going to return false. And this is what I was talking about when it comes to thinking like a programmer, y'all. We have to realize, like, if the up count equals the down count and the right count equals the left count, that means we ended up back at our origin, right? Because if we go up one, like in our example one, we had a, let me see, in our example one, we was right here, right? We went up. Boom. Hold on. Let me set it up for y'all so we could get it right. Boom. Okay. So in our example one, we went with the, my bad, y'all. I don't know what's, in our example one, right? We went up one and we went down one. So that is our up count is equal to down count right there. So, and our left count is 0 and our right count is 0 because we didn't go left or right. So that how we know it's true, right? Because we went up one, we went down one, so it's equal. Say we went left once and then we went right once, then we know we're back at 0 because the left count is equal to the right count, and in that case, the up count would be 0 and the down count would be 0. So they all the up count will be equal to down count and the right count will equal to left count, and that's all we had to do. Go up once, down once, boom, up count equals down count. Go left once, right once, boom, right count equals left count, just like that. And if all those are true, then we're back at our origin, and that's why it's important to think like a programmer, y'all, because it makes the solution that much easier. And now let's run it, see if it runs. It should. Hopefully it does. I don't see why it wouldn't. And it's accepted, y'all. So let's submit it. Make sure it stays submitted. Let's see. And there it is. Ooh, 44 milliseconds beats 7.27% of users with Swift, y'all. We're not worried about the time complexity right now because right now we just want to learn how to solve the problems and learn how to think like a programmer. And this is a great solution for that because we're not making the problem any harder than it has to be. As you can see, it's this simple, y'all, to solve this problem. It might be a little tedious with the code that we wrote, but it's definitely easy to understand, and you can see what's going on right here for yourself, y'all. So I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See you then.